Next, we're going to be looking at rate of change. So the rate of change is the change in one variable relative to the change in another variable, which is exactly what we were doing when we were finding slope. We are finding the change in the y variables on the top when we use the formula y2 minus y1. So that's the change in the y variable. And then in the denominator, it was x2 minus x1. So that's a change in another variable. So when we're dealing with rate of change, we're really just looking at slope in another form. So for try these questions, just fill in these answers by plugging them in your calculator. So I put the answers here for you, and now let's just get into the questions. So Riley is a chef. He is comparing the rates of change in temperature of two ovens. These graphs represent oven temperature versus time. He wants to buy the oven that heats up faster. Which oven should Riley buy? Why? So they gave us two ovens here and a graph that shows how fast they heat up. So the time is on the bottom of the graph and then the oven temperature. So as time goes on, the temperature for both ovens is increasing. So let's figure out the rate of change for each oven. So look on the side, it gives you a hint. It says the rate of change is the slope. So to find the rate of change of both of these ovens, we're going to have to use that formula y2 minus y1 over x2 minus x1. So that is equal to the slope, which is also equal to the rate of change. So to find the rate of change for both of these ovens, I would go and label your coordinates that they give you, x1, y1, and x2, y2. And I'm going to do the same thing for the second graph here. So x1, y1, and x2, y2. So now that we have those labeled, let's plug them into these blanks down here. So starting with oven number 1, our y2 value is 425 and our y1 value is 50. Then our x2 value is 6, our x1 value is 0. So then if we do that, we're going to have 425 minus 50. Well, that gives us 375. And then 6 minus 0 is 6. So if we have 375 divided by 6, that would also equal 62.5 degrees Fahrenheit per minute. So I just converted that fraction into a decimal. And now let's do the same thing for oven number 2. So our y2 is 375 and our y1 is 50. And then our x2 is 5 and our x1 is 0. So then we would get 325 over 5. And if we were to divide those, we would get exactly 65 degrees Fahrenheit per minute. So in question 2, it says, which oven heats up faster? Well, 65 degrees Fahrenheit per minute is greater than 62.5 degrees Fahrenheit per minute. Therefore, oven 2 heats up faster. So which oven should Riley buy? Well, Riley should buy oven number 2 because it heats up 2.5 degrees faster per minute. In our next example, we have Dylan was driving from Regina to Red Deer. After 4 hours, he had traveled 320 kilometers. After 6 hours, he had traveled 480 kilometers. What was Dylan's average rate of change between 4 hours and 6 hours? So first thing we're going to do is we're going to plot the points on the grid and then join them with a line segment. So after 4 hours, he traveled 320 kilometers. So I'm going to go to 4 here and then 320, which would be approximately here, and we'll put a dot. So I'll label that coordinate 4 and 320. And then our other one will be at 6 hours and 480. So 6 hours is here, and we'll go all the way up to 480, which will be approximately here. So 6 and 480. And now I connected those 2 points with a line. So what is the slope of this line segment? So again, we're going to use our formula where we label the points x1, y1, and x2, y2. And now we're going to plug them in here. So y2 is 480 and y1 is 320. And then x2 is 6 and x1 is 4. So then if we do the math, we're going to get 160 divided by 2, and that's going to equal, if we put that in our calculator, 80 kilometers per hour. So now let's talk about what this slope means. The slope is the rate of change of Dylan's distance against time. The rate of change is Dylan's speed. So that's how fast he was traveling, 80 kilometers per hour. What was Dylan's average rate of change? Well, it would have been 80 kilometers per hour. Finally, in our last example, we have that Julia is a heating technician. She graphed the water temperature in a radiator system over a 24-hour period. What is the rate of change for each time interval? What happened in these intervals? So let's start off with the interval from A to B. So what I'm going to do is I'm going to label all of our coordinates on our graph. Okay, so I labeled every one of the coordinate points, and now we need to use the slope formula for each of these line segments. So if I were you, I would label each of them x1, y1, and x2, y2 as you go on, just so you don't get confused with the formula. So I labeled those A and B points x and y 2 and 1. So now I'm going to start off with y2 over here would be 45, and then minus y1 is 24, and then x2 is 7 minus x1, which is 0. So then if we do that, we are going to get 45 minus 24 is 21, and then 7 minus 0 is 7. And then if we do 21 divided by 7, we will get 3 for this first line segment. So now if we're doing B to C, I'm going to zoom in and I'm going to label them x1, y1, and x2, y2 all over. So now I'm going to make this one x1, y1, and I'm going to make this one x2, y2. So now let's plug those into our formula. So I plugged them into the formula there, and 40 minus 45 would give us minus 5, and then 12 minus 7 would give us 5. So minus 5 divided by 5 is negative 1. So that would be the rate of change for that line segment there. And then we're going to do the same thing with the final line segment. So I'm going to zoom into this CD line segment, and I'm going to label those points x1, y1, and x2, y2. All right, I labeled those points, and now we're going to plug them into the formula and solve for that rate of change. All right, so 40 minus 40 is 0, and 24 minus 12 is 12, and 0 divided by any number, well, and divided by 12 would be 0. So the rate of change there is 0. So now let's describe what's going on. So in part B, it says the temperature blanked by blank during the first 7 hours. So we're going to say it increased by 3 degrees Celsius per hour during the first 7 hours. So that's that orange line segment. Then it decreased by 1 degree Celsius per hour during the next. And how many hours did that take? Well, from the point B to the point C, well, if B is at 7 down here and C is at 12, then the amount of time that went by there would be 5 hours. And then finally, it stayed the same for the last, well, from this point here, so from 12 to 24, that would be the last 12 hours.